Hey guys, this is Coach Brian going over the 3.6 practice. All of 3.6 is about proving that lines are parallel. And this is kind of flipping what we learned in 3.4 and 3.5 where we were told, hey, these lines are parallel and able to make, conclusions and conjectures based off of that. Now we're given other information and we're trying to either prove that lines are parallel or find solutions that make them parallel. And so in this case, we have 3 questions, 1, 2, and 3. And for each one, they kind of give us a different pair of angles. And they want us to say, like, okay, if you solved this for x, what x value would make this situation true and make A and B parallel, which is what we're trying to do right here. So for instance, for question number 1, it mentions angle 4 and angle 5, which are here and here. And if you look at 4 and 5, they're same side interior angles, or another word for that is consecutive. And same side interior angles are supplementary. That's what we've learned so far up until this point. That means they add up to 180 degrees. And so when we, that's only true that 4 and 5, same side interior, are supplementary. That's only true if A and B are parallel, okay? Only true if they're parallel. So we need to find what value here for x would make that true, would make them supplementary, and since they're supplementary, that would mean A and B are parallel. So we're going to take their 2 equations, and we're actually going to combine them, and we're going to set them equal to 180, all right? Now, what I like to do when I'm combining like terms, I like to use shapes to show what the terms are that I can put together. So everything with an x attached to it is in a box. So I have a positive 2x and a positive 3x, and when I combine those, I get 5x. And here I have a positive 15 and a positive 15, and when I put those together, I get 30. And so this is simplified. All I did right there was combine like terms, but that's simplified my equation, and now I can continue to solve for x. Divide by 5, x equals 30. So if x equals 30, then that means 4 and 5 together are supplementary. If 4 and 5 together are supplementary as same side interior angles, that means A and B are parallel. So that's kind of how the flow of things is going here. We're kind of reverse engineering what we did in lessons 3.4 and 3.5. So number 2 mentions angle 1 and angle 7. And if you look at their location, okay, they're on opposite sides of the transversal. Opposite sides, so that means they're alternative. And they are also outside of the parallel lines. So they're alternative exterior angles. Alternative exterior angles. And when we are talking about alternative exterior angles, all right, alternate. I knew that sounded wrong. Alternate exterior angles. When we're talking about alternate exterior angles, they are congruent. But they're only congruent if A and B are parallel. So I'm going to keep referencing that because what we're trying to do is we're trying to find a value that proves that these 2 things are parallel. So I want 8x minus 7 to equal 6x plus 21. I want them to be equal because that would mean they're congruent. And if they're congruent, that means A and B are parallel. And so I like to take the smaller x value, okay, in this case 6x, and subtract it from the larger one. That way it keeps my coefficient positive. That will cancel out, and then I'll add 7 to both sides. And so I have 2x equals 28. Divide both sides by 2, and x equals 14. So if x equals 14, then 1 and 7 equal each other. And if 1 and 7 equal each other as alternate exterior angles, then A and B are parallel. I know that that's probably sounding repetitive at this point, but I want you to hear what I'm saying and hear like the way this should be worded over and over and over again, because we ultimately want you guys to be using this same language. Now, lastly, we have angle 2 and angle 6. And if you look at 2 and 6, hopefully at this point you're able to really quickly recognize that they are corresponding angles. They're on the same side of the transversal, and they're in the same position at their intersections. And corresponding angles are also equal as long as the lines are parallel. So we would set these equal to each other. And then again, I would take the smaller value with an x, subtract it from the larger one. That leaves me with 3x. I'm going to add 41 to both sides. So I have 45 equals 3x. Then I'm going to divide both sides by 3. And that gives me x equals 15. So again, if x equals 15, then angle 2 equals angle 6. And if angle 2 and 6 as corresponding angles equal each other, then lines A and B are parallel. All right, moving forward, we have a written response, and we're trying to get you guys to write a little more. Every class, every subject is trying to get you guys to write a little more. And I want you to, everyone always asks, how many words, how many sentences? I want you to write at least 4 sentences on your answer here. And what they're telling me is that if A, B, and C, D, okay, A to B, right here, A to B, and C to D are parallel, let me fix that. They're parallel, so I'm going to put the little mark on them to show that they're parallel. Man, this one side is not cooperating. But I'm going to put the little mark to show that they're parallel. Then if that's true, and also if angle 1 is congruent with angle 2, so I'm going to put a little mark there to show that they're congruent. And also 3 is congruent with 4, so I'm going to put a little mark there so far. What can you conclude about segment BC? Okay, I'm going to put these in red. What can you conclude about segment BC and segment DE? BC and DE. What supports this conclusion? All right, I'm going to give you an example response. I don't want you to copy this. I'm only doing this because I want you to have an example of what a good response to this would be. Your response does not have to match mine, and it shouldn't. Like, I want you to use your own language, use your own words, and at the same time be using a lot of the vocabulary that we've been using in class. So, what can you conclude, and what supports it? So you need a conclusion and support. So I would say if the provided information is true, which we're assuming it is because it's given, then segments BC is parallel to segment DE. That's my conclusion. I conclude that BC and DE are parallel. How do I know that? Well, my main thought kind of goes to the fact that 1 and 2 are equal, 3 and 4 are equal. That's what I'm really focused on right here. And the fact that 1 is the angle of a line that's parallel to the same line as angle 3, that lets me know that these two are congruent. And through transitive property, if 1 equals 2 and 1 equals 3, then they equal each other, but also 2 and 4 equal each other. And the fact that 2 and 4, that I'm going to put in yellow, the fact that they are the same angle tells me that the slope of BC and DE match. The slopes of BC and DE match. And if you have matching slopes, lines are parallel. So let me see if I can find the same color I was writing with. I think that's it. So my conclusion is that they're parallel. BC is parallel to segment DE. So I could say segments BC and DE both intersect line AE, right there, A to E. They both intersect line AE at the same angle. Since they cross AE at matching angles, they must also have matching slopes. Lines with matching slopes are parallel. The end. 4 sentences that give me a good conclusion and support to that conclusion using the language that we have been using in class. I hope this helped. I hope that this helps you understand better the converse statements as well as a quality written response defending a conclusion. I will see y'all